What is up, CoderByte? Welcome back to another data structures and algorithms video. I'm Elizabeth, and today we're probably going to be doing our last problem in the sliding window pattern chapter of this interview patterns series that we got going on. This is going to be, I would consider this kind of a, hard, medium hard problem. So, it's going to be taking some of the concepts that we've already learned in our last couple videos. So if you haven't seen those already, I do highly recommend checking them out. Of course, this video does stand on its own though, if you just want to watch this one. So without further ado, let's get into it. So we will, as per usual, just review a little bit what this pattern is all about. So this pattern is called sliding window. And in general, we use this pattern with problems involving arrays or linked lists where we're asked to calculate something among the subarrays, of a given size. Different problems will ask for different kinds of subarrays, right? So often these subarrays overlap, which allows us to optimize our algorithm. So we don't have to recompute all of those overlapping sections. Rather, we can use a sliding window to kind of look over the array or the linked list all in one go and either grow or shrink the window as needed and look at the subarrays within the window, right? So that allows us to not have to loop over that array over and over and over again. Depending on the problem, we can use the sliding window to look at the different smaller subsections of the array, but really only loop over the array one time. So that's essentially what the sliding window pattern is all about. And there are a lot of different kinds of problems that call for using this sliding window, but I hope you're starting to understand this is I think the third window in this chapter of our series that there are certain pieces and almost like ingredients for these algorithms. The variables are similar, it looks very similar with just slight modifications depending on the problem. So if some of this seems repetitive, that's a good thing, because that's the whole point of this series, is understanding what's actually the pattern that we can apply to many different problems, and then what are the smaller pieces that we kind of add in or remove depending on the individual problem that we're asked. So what is the problem this week? Given a string, find the length of the longest substring that contains no more than k distinct characters. So let's use an example to kind of illustrate what this is actually asking. So here we have a string. You can see it's just a bunch of gibberish. It's just a bunch of letters. There's an A, C, 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 P, etc. And then our k here is 3. So the question is, what is the longest substring where there are only k distinct characters? So in this case, what is the longest substring where there are only, at a maximum, 3 distinct letters? So we can see here that the answer to this problem would be 6, because the longest substring with only 3 distinct characters is this CCCPBB. Another substring that has 3 distinct characters might be, BBEBI, right? That also has 3 distinct characters, but that is only 5. The length is only 5 of that substring. So this would be the correct answer because it's the longer string. But that's sort of the general kind of what we're trying to accomplish here. Okay, so what is our sliding window approach for this problem? How are we going to actually use the sliding window pattern to solve this problem? So I have kind of an example right here, right? It's the same string as before. K is equal to 3. And again, these are the same variables that we've been using all throughout this chapter of this series. Window start, window end. The longest substring so far is similar to our, longest or character, whatever. I forget the other problems, but it was a similar kind of idea of like, what have we seen so far? What's the longest, whatever. And the difference here is that we need some way to track the letter frequencies. We need to know how many are there of a certain letter in a substring, because we have to know that there are a certain amount of distinct letters, right? We can only have a maximum of k distinct letters. And the only way to really track that is to keep track of how many letters, what letters have we seen, and how many have we seen so far. And you'll understand once we walk through this why it's important to know how many have we seen so far, because you might think, well, why do I have to know how many of a letter I've seen? I'm already tracking the size of the substring with that window start and window end. Why do I have to know the amount of letters in the substring? And you'll see why that's important in a second. But just know for now that this is going to track the letters in the window and how many of those letters are in the window. So let's begin, right? This is, again, similar to other problems we've done. Here's our first kind of iteration of our loop. This arrow is the window end, I think, and this is going to be the window start. And then the yellow letter, or whatever the letters are that are yellow, are kind of, those are the letters that are within the window at the given iteration. So here we have our window start initialized at 0. We have our window end initialized at 0. Again, these are indexes, right, or indices, right? So it's the 0th index that we're starting with. And the longest substring we've seen so far is just of length 1, right? It's this A. That's the longest we've seen so far. So the first thing we do is we add our letter to our letter frequencies tracker. And we see we have our key, which is the letter itself, and then our value, which is how many we've seen so far. It's 1 so far. And then we have our longest substring so far is 1. So we maintain that, we keep track of that as we go. So what do? We ask ourselves, are we at k yet? Have we seen more letters in this substring than k allows for? The answer is no. So we grow our window. So we move our arrow, right? We increment window end, right? So we have our incremented window end, which is now at index 1, and we get a new letter. So the first thing we do is we add it to our letter frequencies, and we get C in there, and we have a frequency of 1, right? We've only seen 1 so far. And of course, we now can say that the longest substring so far with k distinct letters is now of length 2. So we increment that as well over here. So have we reached our capacity? No, we have not. So we grow our window. So we move our arrow, we get another C. So instead of, obviously adding another key that's C, which we can't do, we're just going to increment that frequency. Excuse me. We're going to increment our window end, right, to represent that we've grown our window. And now we are going to increment our frequency of C. And you'll see in a second why that's important, why we're keeping track of how many C's we have versus just that we've seen 2 distinct letters. So, okay, so we have our window has grown. We're still under the limit, which is K. So we add, for our longest substring so far, we now have seen is of length 3. What do? We're still under K, right, in terms of how many distinct letters we've seen. So we grow our window. Grow our window one more time, increment window end to denote that the window has grown, and we see another C. So we increment our C frequency, and we are very happily adding another element to our longest substring so far. So now we have a longest substring of 4, and so we go. Increment our window end, right? We grow our window. Now window end is at 4, and we see another different distinct letter finally. So now we have a P. What do? We add it to our letter frequencies. There it is. We have only one P, and we are still at, equal to or under K, right? So now we finally have our 3 distinct letters, which is allowed because, we have to have at most K. So we're good. We can continue to grow our window. And our longest substring so far is now going to be 5. Okay, so we grow our window again. And now this is where it's going to become obvious why we're keeping track of the frequencies of our letters. So we get to B, right? And at this point, we already have our max capacity of distinct letters. So what do? Well, our first thing we do is we're going to increment window end, right? And the next thing we do is we have to shrink our window. We have to somehow get back down to the K distinct letters. And at that point, as we start to shrink that window until we get back to that K distinct point, that is only at that point can we grow our window. So why did we have to keep track of our frequencies? Because we need to know that as we shrink our window, are we actually removing all of those, that specific kind of letter? So in this case, we've now decremented our A frequency, so we can remove it from the window. Now, if we shrink our window, if we shrank our window and we had another A in there somewhere, we'd still have A in the window. So we couldn't just assume that because we shrank our window, we actually got rid of all of the A's. So that's why we keep track of the frequencies, because we need to not only know what are the distinct letters within the window, but we also need to know what are the distinct letters within the window. And the only way we'll know that while we're growing or shrinking is by keeping track of how many of those letters are in the window at all. So I hope that makes sense. So now we're going to shrink the window, right? So we can remove A because we just decremented it and it was at 0. And then we can finally increment our window start, shrink the window totally. And at this point, our window now again has less than K, right? We only have C's and P's. Or no, we have C's and P's, and now we want to add our B, right? So this is where that's our incrementing of our window start. And we can add our B to our letter frequencies. And we are happy again, we only have 3 in our letter frequencies tracker, and our longest substring so far is still 5, so that stays the same. Okay, so what do we do now? We can grow our window again because we still maintain only 3 distinct letters in our letter frequencies tracker. So we increment our window end, we slurp this next B into our window, so window end becomes 6, and we have another B, right? So we just have to increment our B frequency and our letter frequencies, and now we actually do have a longer substring than 5. Now we have 6, so that's excellent. And so we go, right? So now we increment again, we get an E, same deal, right? We can't add E yet because we already have 3. So what do we have to do? We have to shrink our window. So, well, first we increment our window end here, right? And then we start to shrink our window. So we increment window start now. And now here's a good example of where we shrink our window, but we still have C's left in the window, right? So we still have this, we still have 2 C's left just because we've gotten rid of that first C. So what do? We shrink our window again. Okay, so we shrink our window again, we increment window start, and then we decrement C again, and we still have C's, right? So we got to shrink our window again. So we shrink our window, increment window start, and then we finally have a 0C. We can get it out of our letter frequencies and make room to add E into our letter frequencies, right? So here we have E in our letter frequencies. And, obviously this is only 4, so we've already seen a longer substring, but that's kind of how we inch our way through the entire string, growing and shrinking depending on how many distinct letters we've seen so far and what letters are in the window. So, step through this yourselves, you know the drill by now, but I think in code this also maybe becomes a little bit clearer. And it's a very cool algorithm because I think it combines a bunch of different skills that we all have as developers. We know how to interact with strings and arrays. And this is kind of taking this concept of a sliding window and really tracking letter frequencies is easy. We can all do that in our sleep practically, but kind of using the concept of tracking letter frequencies along with the sliding window makes this a very powerful algorithm, and what I would say is a harder problem, even though the actual pieces of this are quite simple, and I think something that we could all do very, very simply. So walk through this with a few different examples, and we'll code this out, but this is essentially the algorithm. So let's summarize the algorithm, and this is just going to be summarized in English, right? So first we initialize that window start and the window end at the 0th index. That's the same. We also, this is the different step, we add that character in the window to the letter frequency tracker if it doesn't exist there already. We then increment that character frequency in the letter frequency tracker. And then we ask ourselves, is the number of letters in the letter frequency tracker greater than K? If yes, we shrink the window until the letters in the letter frequency tracker are once again less than or equal to K. And at that point, we repeat from step 2. When we get back down to K distinct letters in our letter frequency tracker, we know we can grow our window once again. Now, if the number of letters in the letter frequency tracker are not greater than K, right, we can grow the sliding window to the next element by incrementing that window end. Capture the window length in the longest substring so far, right? So that's, at that point, we have a substring with K distinct letters, or less K or less than K distinct letters. So take whatever, the maximum of the window length at that given point and what we've seen so far as the maximum, longest substring so far. And then repeat from step 2. So that's kind of the algorithm. And I think it's really important to, number one, understand this algorithm. But number two, compare and contrast this with the other problems we've done and kind of see which pieces of this algorithm are really exactly the same and which pieces are slightly different. So you start to get a real feel for what's the word, like when you build a house and you got all of the structural pieces in place, what are those pieces for this pattern, and then what are the actual kind of customizations that you can add in depending on the actual problem? Because I think that is the important piece here, that you understand what does the sliding window pattern look like, what's similar about the sliding window pattern across every problem you get versus the things that actually, make it unique to whatever problem you've been asked. So let's code this out. All right, so as per usual, I'm just in my Visual Studio Code editor and I just have a blank file for the moment. So let's get into this. I think the first thing I'm going to do is I'm going to add some test cases in here. So let's say console log, and let's maybe define our function. We can call this, I don't know, longest substring with K distinct characters. That's a mouthful. And let's, finish that out. Okay, so let's call this here with some test cases. So I have some test cases. I have the same one that was, I think, in the slides. So let's add that in right here. So that first thing that gets passed is going to be the string, and then the second thing is going to be that K, right? So we can add that in here too, right? Just to make it nice and obvious. And then I have a couple other test cases that I'm just gonna paste in here. So here is, let's see, we have another one, and let's say K is equal to 1. So, and we'll talk about what each of these should be returning if we do this correctly. And then we'll do console longest substring so far, and I'm going to take one more. And then we can make this a K of 10. So this one is the same that was in our slides, right? So I think we're expecting 6 here. So that would be this, 1, 2, 3, 4, 5, 6, that substring. And then this one, a K is equal to 1. So this is really asking, right, what's the longest substring where there's only one letter? So I think here that's going to be this A. So that should be 4. And then here it's 10, right? And we only have A, B, C, D, E, F, G, so that's less than 10. So we're going to expect that the whole string is actually the longest substring with K distinct characters, 10 distinct characters, right? So that's just going to be 7. Okay, so that's kind of what we're expecting. Let's code this out. So the first thing we want to do, just like, again, like our other problems that we've done, is initialize those variables that we know we're going to need. So we're going to need a window start, and that's going to be equal to 0. And then we're probably going to need, right, a letter frequencies tracker, right? So that's just going to be an object. And then we are going to need our longest substring so far, and that's just going to be initialized at 0. Okay, and I think that actually takes care of most of the variables we are going to need. So again, like our other problems, we're just going to basically start a for loop, and that's going to be it's going to represent our window end. So that's going to be is that how you do a for loop? No, it's not. Let I, and we don't want to use I, right? So this is going to represent our window end, right? So let window end equal to 0, while the window end is less than the string dot length, right? And then we are going to that's not how you spell length. And then we're going to increment window end, right? So there's our for loop that's going to kind of represent that window end. And we're just going to loop through this string until we have a maximum amount of letters in our letter frequency tracker. And at that point, within the for loop, right, we don't want to increment window end. We want to be shrinking our window and keeping track of how many letters are actually in the window at any given point, and then just doing a simple math.max, right? Math.max for our longest substring so far, compared to whatever the window length is at any given point. So the first thing we do in our kind of iteration is we want to know what is that last character, right? What's the end, what is the character that we've just added to our window? And so that's just going to be whatever is at window end, right? So this is going to be the window end character, and that is the string at whatever is, the index of the window end in that iteration. So for that first iteration, the window end character is just going to be that first character, which is at the 0th index. And that's going to be kind of the letter that we're trying to add to our letter frequencies tracker. So, please don't do that. Thank you, editor. Okay, so we want to, answer this question, right? Like, if the letter hasn't been seen yet, we want to init it, right? We want to initialize it in the letter frequencies tracker, right? So that's like, if it's not there yet, we want to init it, and then we also want to increment it, whether we've seen it or we've just initialized it at 0. So that's very easy. We can just say if, letter frequencies tracker at that window end character does not exist yet, we just do letter frequencies, right? Letter frequencies at the window end character. No. Letter frequencies at the window end character is just going to be equal to 0, right? That's like essentially just initializing it. And then we can increment it to represent that it's in the window. We're adding it to the window, right? So then we just do, I got to uninstall that Emmet autocomplete. I haven't written HTML in a million years, and it's constantly making me have code that's HTML that I don't want. Okay, window end character right? Okay, so at this point, we've now added it to our window frequencies tracker. So what do we want to do here? We basically want to know, right? We want to ask ourselves that question, which is kind of our, it's our, what do you call that? Like a split in our logic. Do we have too many characters in our letter frequencies tracker? If yes, we need to shrink the window. And if no, we just continue, right? So this is where we kind of check that. So we can do that kind of by wrapping the next piece of code in a for loop, in a while loop. And the while loop will only get called if the while condition is true. So this is going to be, we're going to wrap our shrinking window code in this while loop that will only get called while the letter frequencies tracker has too many letters in it. So we can do that right like this, right? We could say while the object.keys, right? So we're going to basically be checking the length of the the length of the keys in the letter frequency tracker. So while that is greater than k, so then, so this code is only run if we need to shrink our window, right? So what this is kind of denoting is we have to shrink our window. And if we don't have to shrink our window, we can continue just iterating and growing our window, which is what that all represents. So this is if we need to shrink our window. So what do we have to do if we are shrinking our window? The first thing we need is what is the character at the beginning of the window? Because we need to, right? We need to remove it from the letter frequencies tracker. So to do that, right, we can just take the, right, we're going to do something similar to what we did above. Let the window start character equal to the string at the window start, right? So that now we have our, God damn it, Emmett. Okay. So now we have our window start character, which is the thing we want to remove from the window. And what do we do with it? We want to remove it, right? So what do? We do letter frequencies at that window start character minus, right? Okay, so this is, right, we are removing a character from the window. That's what that's kind of doing. Now, what else do we have to do, right? We have to delete it if now we are at 0, right? We want to actually get rid of it from the letter frequencies tracker. So we can do if the letter frequencies at that window start character equals 0, we can delete it from the letter frequencies tracker, right? So we can just delete that entry. So that removes it from our letter frequencies tracker, right? And then, of course, we have to actually shrink the window, which is, basically done with that window start variable. So we've now deleted it from the letter frequencies tracker. We've incremented our window start. And so at the end of this iteration of the while loop, we will once again check are the keys of the letter frequency tracker greater than k. If it's still greater than k, we do this again, right? We'll do this until we delete the amount of keys that we need to get back down to k, right? Because remember that we're going to have to continue to shrink our window if this doesn't happen. We have to shrink it until that happens and we actually remove a letter entirely from our window. So this will run until we're back down to the proper amount of letters in our letter frequencies. And once that happens, what do we have to do, right? So this code right here represents that we have the correct amount of letters in our window. And whether that was done just by growing or shrinking, it doesn't really matter. And at that point, we need to actually capture how many characters are in the substring, right? So that's, again, very easy. We say the longest substring so far is equal to the math.max of the longest substring so far, and then whatever the window end is minus the window start. And remember, these are indices, so for length, we still have to add that +1, because if the window end is 4 and the window start is 0, that actually represents a string of 5 characters, but 4 minus 0 is just 4. So we add that 1 because the length and the indices thing, which we all know and love so well. And that's how we kind of keep track of that longest substring so far. And that is the entire algorithm, right? All we have to do now is return that longest substring so far. And that takes care of that. So just to go over this again, because I know this is, a slightly harder problem than we've done so far. We keep track of our window start in a variable up here, but we actually manage our window end with this for loop. So every single iteration of this represents growing the window. And if we grow our window such that the letter frequencies exceed k, we shrink the window until it doesn't anymore, right? And regardless of whether we've been shrinking our window or we've just been growing our window, after all of that, we capture what is the longest substring we've seen so far, and how does it compare to the other, whatever value we've already gotten for our longest substring so far. And then at the end of our, iteration, right, when the window end equals the end of the string, we're done. We just return that longest substring. So let's see what we get here if we run this code. No, I don't want to update you on my Zish right now. All right, CB videos, patterns, longest substring, and let's node code this. And we get 10, 10, and 7, which is not at all what we expected. So I wonder why that happened. So let's kind of debug this together. I'm going to get rid of that. So we have our window start, our letter frequencies, and our longest substring so far, right? And then we have our window end, and then we have our window end is less than the string length. I think that is all correct. And then if we haven't seen it yet, we initialize it at 0, right? That's our window end character. And then we increment our window end character, right? Aha, okay, so this object.keys, we need to actually check that the length of the object.keys, right? Because object.keys returns an array, right? So this is not going to actually do anything. So let's say object.keys.length. All right, let's see what we get here. And we do, in fact, get 6, 4, and 7. Muy feliz. I think that means very happy in Spanish. I'm trying to learn Spanish, because I'm in Mexico. Muy feliz. Okay. Muy excelente. And that's the algorithm. So I, as always, recommend you kind of go through this with a debugger, go through this with different examples and all of that fun stuff. But this is kind of, I would say, a more difficult problem using the sliding window pattern. So I hope you enjoyed coding that out. And that's it for this week's problem and the sliding window pattern. I think next week, we'll be doing a new pattern, so get ready for that. This is my last video also for Mexico for this trip, so I'm sad about that. But I hope you all have enjoyed this. I think it's really valuable and important to kind of start to really visualize the building blocks that make up all these algorithms, because this is a skill that is actually transferable to actual coding and actual, engineering and developing. When you start to see certain pieces of code as almost self-contained modules that you can then use to build as building blocks to build bigger empires, rather than kind of that spaghetti code of every line for itself. You know what I'm saying? Like, there are certain pieces of this pattern that you can use almost as, you can think of it as a module or a library, and then use it as you need. And I think this problem in particular is really, it's a great problem to kind of see what were the building blocks that we have been using for every single problem we've done for this pattern versus the pieces of it that kind of make it customized to a particular problem. So happy holidays, everybody. I hope everyone is taking some time off and really just enjoying things outside of computers, or enjoying computers if that's all you enjoy. But it's good to have other hobbies. And yeah, see you next year.